Welcome to Note 1.1a for Math 8. Please stay with me so you can do the assignment next time you have me in class. In this video, our goal is to learn about exponential notation. Below, we have some examples involving exponential notation where we will need to identify the base and the exponent. In number 1, we have 5 times 5 times 5 times 5 times 5, which means we are multiplying 5 by itself 6 times. So that will give us 5 raised to the 6th power. Now the base is the number that's multiplied by itself repeatedly. So here we have a base of 5. The exponent tells us how many times to multiply it by itself, and so here the exponent is 6. Number 2 would be 9/7 raised to the 4th power, because it's multiplied by itself 4 times. Now this is crucial. It looks at this point like just the 9 is raised to the 4th power, when actually the whole number is raised to the 4th power. So we must include parentheses so that we know that the whole 9/7 is raised to the 4th power. So we have a 9/7 as the base and a 4 as an exponent. Now, number 3 is opposite because we are given exponential notation and we're going to write it out in standard form. And so this means I'm going to multiply -4/11 times a -4/11 times -4/11. And so the base here is -4/11 and the exponent is 3. Number 4. We have -2 multiplied by itself 6 times, which means we would write -2 times -2 times -2 times -2 times -2 times -2. So here, -2 is going to be the base, and 3 is going to be the exponent. Okay, so let's scroll back up here for just a bit. There's a box that says, did you notice that parentheses are used in 2, 3, and 4? Why do you think there are parentheses? Well, number 1 should be obvious because there's just one single number being raised to the 6th power, and we know that that number was 5, okay? Number 2, a little more tricky because we have an actual fraction right here, 9/7, and we needed to make sure that we used parentheses to show that the whole fraction was raised to the 4th power. In number 3, the same thing applies. It's a fraction, -4/11. Now in number 4, something tricky happens. Now without parentheses, down here on number 4, we would have -2 to the 6th power, so again, pretending there are no parentheses there. What does that really mean? That means that we have 2 times 2 times 2 times 2 times 2 times 2, 6 of them because it's to the 6th power, and because there are no parentheses, that negative sign is just going to be placed right out front. And that is different than what our original equation was saying. So actually it is incorrect. In order to indicate that the whole -2 is raised to the 6th power, we would need parentheses. So back up here in that box, let's answer the question here with this. To show the entire number that is the base. So again, why do we need parentheses? It really is going to matter if we have a fraction as the base or if we have a negative sign as the base. Okay, let's scroll down to the next page. We should be on page 3 of your notes. What I'm going to do is be your partner here, so I want you to press pause. I want you to try these questions on your own, and you're going to come back and you're going to compare your answers to my answers. Okay, welcome back. For number 1, I have 4 to the 7th power. With or with parentheses is fine. With or without parentheses is fine. For number 2, 3.6 raised to the 47th power means that 3.6 is multiplied by itself 47 times. Number 3, We have a negative 11.63 multiplied by itself 34 times. So we have negative 11.63 to the 34th power. And parentheses are required because the base is negative. In number 4, we have an exponent of 15, and so this means that 12 is multiplied by itself 15 times. In number 5, we have negative 5 multiplied by itself 10 times. So we must have negative 5 raised to the 10th power, and parentheses are absolutely necessary here because the base is negative. Okay, moving back up to number 6, we have 7 over 2 multiplied by itself 21 times, and so we would write this as 7 over 2 raised to the 21st power, and we would definitely need parentheses to make sure that we know that it's the 7 halves raised to the 21st power, not just the 7 or not just the 2. Okay, in number 7, we have negative 13 raised to the 6th power, and we need parentheses on this one. Number 8, we have negative 1/14 raised to the 10th power, and we need parentheses on that one. In number 9, x is multiplied by itself 185 times, so we have x to the 185th power. In number 10, the exponent is n, so it is multiplied by itself n times. In number 11, will these products be positive or negative? How do you know? Well, in the first question, we have negative 1 multiplied by itself 12 times. That's kind of a lot, so let's start with a simpler problem by multiplying negative 1 by itself twice. So we get negative 1 times negative 1, and that should produce a positive 1. Well, what happens if we add another negative 1 outside? So we would pretend if we did have another negative 1 that was multiplied, that would turn into positive 1 times negative 1, which in this case will give us a negative 1. So now let's apply this rule to the first question by writing out all of those negative 1s multiplied by themselves 12 times. So we'd have negative 1 times 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 negative 1 gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 2 more. And we'll pretend that we had 1 there. Okay, so we have 12 of those. We know that each pair of these negative 1s will multiply to give us positive 1, because a negative times a negative is a positive. And so if I were to box in each pair of partners, there's a positive 1, there's a positive 1, another positive 1 here, another positive 1 here, here's another positive 1, and here's another positive 1. So all of these end up giving us a positive answer because positive 1 times positive 1 is positive 1. So I guess what we would write down over here, will the products be positive or negative? Well, they will be positive. Well, the next question says, how do you know? Well, it all has to do with the number of factors. So in the first question, we had 12 factors, right? In the second question, we have an extra factor. We have an extra negative 1. And if we were to go back up here and look at the 12 negative 1s that we wrote out, this would be that extra factor. So there's the 13th negative 1. And it's not being multiplied by any more negative 1s, which means that we have all positive numbers multiplied by a negative 1. So that would give us a positive answer multiplied by negative 1, which that would give us a negative answer. So I want you to think about this for a few minutes. I want you to press pause and see if you can figure out how you know if the product will be positive or negative. Welcome back. Hopefully you figured out that the first answer is positive because the exponent was even. So when you have an even number of factors, the even numbers are going to multiply together to give you a positive answer, and those are all of what we boxed in above. As soon as you have an odd number of factors, though, you have a negative number that doesn't have a partner to change it to a positive, and that was this negative 1 up here that we had. That means the answer is going to turn out to be negative, and so the reason that the second answer was negative is because the exponent is odd. So let's scroll down to page 4. Number 12, the question asks, is it necessary to do all of the calculations to determine the sign of the product? Why or why not? Well, all I want to know is, will the product be positive or negative? Now, we could multiply negative 5 by itself 95 times, but that would really take a long time. So let's use what we just learned. It comes down to the exponent. In this case, the exponent here is 95, so that exponent is odd, which means that there are 94 of the negative 5s that are going to be multiplied together and having a partner, but there will be one left over, which means we will have a negative answer. So in this case, what I would say is our answer should be no. It is not necessary, and all you have to do is look at the exponent. So in this example, the product is negative because the exponent is odd. So in the next question, it's not necessary either. Again, all you have to do is look at the exponent. So here the exponent we have is 122. That number is even, so I would say the product is positive because the exponent is even. So go ahead, pause the video, and fill in the blanks for question number 13. And when you are done, come back and see if your answer matches mine. Welcome back. For the first blank, if n is a positive even number, then negative 55 to the nth power is positive. Now, if n is a positive odd number, then negative 55 to the nth power is negative. So let's move to number 14. In number 14, Josie says that negative 15 times 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 negative 15 is equal to negative 15 to the 6th power. Is she correct? How do you know? Well, since we have 6 of the negative 15s, we have we have 3 pairs that will become positive. So this is positive, and this is positive, which means the final answer right here is going to be positive. The reason is you have 3 positive numbers multiplied together. It'll still be positive. But if we look at what this equals, we see that the base is just 15. We talked about this before. What this means is that 15 is multiplied by itself 6 times. So this is really negative 15 to the 6th is equal to, we should have 6 of these, 15 times 15 times 15 times 15 times 15 times 15. And the negative sign right here simply is just tagging along right out in the front, which makes our answer a negative number. So she is actually incorrect because there is no possible way that a positive number here could be equal to a negative number here. Now remember, the base was just 15 because without the parentheses, the negative is not part of the base. So the answer to this question is no, she is not correct because negative 15 to the 6th power is negative, while her product should be positive. It should say negative 15 to the 6th power, where the negative 15 is in parentheses. So let's look at number 15. In exercise 15, I hope we remember how to multiply fractions. We multiply the numerators by numerators and denominators by denominators. So we have negative 3/4 times negative 3/4 times negative 3/4. Now, in the numerator, we have 3 times 3, which is 9, times 3, which is 27. And with an odd number of negatives, we should get a negative 27. In the denominator, we have 4 times 4, which is 16, times 4, which is 64. So the negatives are for only one of the numbers. I chose the negative sign to go with the 3. You could choose it to go with the 4 and still get a negative answer like we did. Just make sure that the negative sign only goes with one and not both.